Hello there. In this presentation, we're going to discuss about the rational algebraic expression. Oh, never mind about the pictures, you know. Okay, so what is rational algebraic expression? Let's go directly to the definition of rational algebraic expression. A rational algebraic expression is an expression containing the numerator and denominator that are both polynomials. It is an expression of p of x, q of x in the form of p of x over q of x, where q of x is not equal to 0, of course, because the denominator must not be 0 and to avoid the undefined operation of division by 0. So let's have an example of a rational algebraic expression with this variables p of x. This is actually the numerator that represents the x squared plus 3x plus 2. Okay, so this is the numerator. And we have the denominator q of x. It represents also the x squared minus 1. Again, that is the denominator, where x is not equal to 1 and negative 1. This is also to avoid the undefined operation of division by 0. So imagine if you have to substitute the 1 to the denominator, so it gives 0. Okay? Let's continue to understand more about the algebraic expressions or the rational algebraic expression. Let's learn the non-rational algebraic expressions. So how do you say that the expression is not a rational algebraic expression? So remember that a certain expressions are not rational algebraic expression due to the presence of radicals, negative exponents. So let's have an example of this. Okay, so 2 square root of x over 3. So the numerator here is 2 square root of x that contains the radical sign. And the denominator is 3, which is a polynomial, but it is a constant with the degree of 0. So both of these two, combining these two, is not a rational algebraic expression. Okay? Another thing is that if an expression includes a negative exponent, so we have here an example. As you can see, we have a negative exponent in the numerator and the denominator. So this is not also irrational algebraic expressions. So remember that polynomials are defined as sums of the terms consisting of a coefficient multiplied by a variable raised to a non-negative integer power. Okay, so it must be non-negative and there is no radical. But of course, there is an exception. Let's continue. Alright, here is the exceptions. Number like square root of 4, square root of 9, square root of 16, etc. are exceptions because they simply to integers 2, 3, 4 respectively. When simplified, they no longer include a radical sign. Just like this, when it's the square root of 4, that is 2, square root of 9, that is 3, square root of 16, that is 4. This is because it does not violate the rule about the radicals in the context of a rational algebraic expression. So these specific values are exceptions because they are perfect squares and simplified to integers, which are polynomials of degree of 0. Okay? That's why it is really important for us to determine the perfect example of a rational algebraic expression. So let's have this number 1. It is an example of rational algebraic expression because both numerator, the x plus 1, and the denominator x minus 1 are polynomials. Okay? And number 2, 3x squared plus 2x over x squared minus 4. This is a polynomial. This is a rational algebraic expression because they are both polynomials. Alright? And then number 3, we have 1 over x. This is also a rational algebraic expression because the numerator is 1, a polynomial of degree of 0. And the denominator is x, a polynomial of degree of 1. Okay, so it does not violate the rule of a rational algebraic expression. And number 4, we have 5 over x squared plus 3x plus 2. So why it is considered as a rational algebraic expression? Because the numerator is 5, which is a polynomial with a degree of 0. And the denominator is x squared plus 3x plus 2, which is a trinomial. Okay? So, I have you. Okay, so here is the example of non-rational algebraic expression. Okay, so to apply what we have learned about the rule of a non-rational algebraic expression. So number 1 here is the square root of x plus 2. It is not a rational algebraic expression. Why? Because this is not a fraction. The square root of x is not a polynomial. Okay? And let's have number 2. E raised to x plus 1 over x. It is not a rational algebraic expression because although it contains fraction e raised to x, it is not a polynomial. It is an exponential expression. Do you get that? Okay. So number 3, log of x plus 1. It is not a rational expression or algebraic expression. Why? It is because log of x is not a polynomial. It is a logarithmic expression. So that is the answer. Another non-rational algebraic expression examples are here. We have number 4, 3x plus 1 over square root of x. Why? While it is the fraction, the denominator square root of x is not a polynomial because it involves a root. Okay? In number 5, we have x squared plus 1 over x plus sin over x. So why is it that it is considered as a non-rational algebraic expression? It says here that while it is a fraction, the denominator x plus sin of x is not polynomial because sin of x is a trigonometric function. Take note of these examples. Okay? So here is the exercise for us, okay, to test your knowledge about the rational algebraic expression. So let's discuss number 1 and number 2. Key over m squared plus 3 key, and the number 2 is x plus 2 over x minus 1. So let's determine if it is a non-rational algebraic expression or a rational algebraic expression. So let's begin with number 1. Alright, so it is a rational algebraic expression because the numerator is a polynomial with degree of 0 and then the denominator is a polynomial with a degree of 2. And definitely, yes, it is a rational algebraic expression. Okay, how about number 2? Okay, it is also a rational algebraic expression. So as you can see in the numerator, it is a polynomial, and the denominator is a polynomial also with degree of 1. Alright, so you should know how to explain why is it a rational algebraic expression and why is not an irrational algebraic expression. And your turn is to answer the next exercise. Okay, so you are going to answer number 3, number 4. So comment section. Comment your answer And thank you so much for watching. Please like and subscribe for more review lessons about math, science, and etc.